This is a solution video to G2, which is a calculator problem. First thing you'll notice is at the top of the problem is a chart. We commonly call this a chart problem, where it has a bunch of data organized into a chart. This one happens to be the temperature of T versus time. First recommendation I would have is anytime you see a chart problem, somewhere in your solution to sketch a graph. This one happens to be a trapezoid rule, which we'll get to in a second. Part A says, using the data in the table, approximate the rate at which the temperature of the T is changing. Okay, so as soon as we see the word rate would imply that we're talking about a derivative. And so we need a derivative. And how are we going to take a derivative when we don't have the equation of the function? So then we start looking at information about the function, and that is we have a set of data points and we're looking for the derivative. There's also a keyword here which is approximate, and approximate is going to indicate that you're not going to actually take a derivative. You're going to probably use some type of slope function. There is another issue here, and that issue is that you'll notice they're asking you to find the derivative at the point 3.5, but 3.5 is not on the chart. It's in between 2 and 5. And so what we're going to do is we're going to approximate the slope of the tangent line by finding the slope of the secant line. For those of you that are visual learners, what that means is we've got some function that goes like this, where we've got 2 over here, we've got 5 over here, and we want to know the slope of the line of the tangent line at 3.5. But the problem is we don't know the equation. So what we're going to do is we're going to approximate the slope of the tangent line by finding the slope of the secant line, which is a straightforward Algebra 1 slope calculation, which you can see in the solution to problem number 1. Where we are, here we are. So h prime of 3.5 is approximated by taking the slope of the secant line, which is h of 5 minus h of 2 over 5 minus 2. Doing the math there and getting the data from the chart, we end up with a value of negative 2.666 or negative 2.667. Quick reminder here, have to be accurate to 3 decimal places. So why are they accepting 0.266 or 0.267? Because they will accept either a truncated or a rounded answer. Truncated, you just chop off everything past 3. Rounded, you round that last number. The scoring on this is 1 point for the correct answer. So they don't care about work in this case. They don't care about how you got it. They just want to see the answer negative 2.66. However, since you don't know how they're going to grade it, it is a good idea to show your work to get to that solution. Part B says using correct units. That's an indicator that you want to include units to get points. Explain the meaning of 1/10 times the integral from 0 to 10 of h of t dt. Looking at the integral, we have a whole series of ideas about what the integral could be, but really it's that 1/10 in front of it that's an indicator. You'll notice that 1/10 is actually 1 over 10 minus 0, and so that actually ends up being an average value. And so as the solution says here, it is the average temperature of the T over the 10 minutes. Okay, and then you'll see in the problem, use the trapezoidal rule, or sum, to find the 4 subintervals indicated by the table. Okay, which leads us and add that up. And so what they're doing in their solution is they're actually applying the trapezoid rule, which we really didn't cover in class that much. If you memorized it, then it's an application. What they're looking for there is some work. Common mistake in a problem like this is forgetting that 1/10. Okay, and then the scoring is 1 for the meaning. Did you know that that is an average value? Number 2 is the trapezoidal sum, taking the value of the sum of all those trapezoids. And then the other one is the estimate. So the estimate is that actual final answer there. In other words, they're giving you a point for recognizing that you need to multiply by 1/10. 3 points for that guy. Part C, evaluate the integral from 0 to 10 of h prime of t dt using correct units. Explain the meaning of the expression in the context of the problem. So what happens when you take the integral of a derivative? Well, it cancels itself out. And so it's like taking the square root of a squared, or any one of those other inverse functions. So because it's a definite integral, however, we still need to plug in 10 and plug in 0. So you'll see in the explanation here, the integral and the derivative will cancel each other out, but you still have to plug in 10. So we get h of 10 minus h of 0, which are values that you just get from the chart up above. Plug and chug, and you get your answer of negative 23. Now, the hard part of this problem, in my opinion, is what does that expression mean? It means that the temperature dropped 23 degrees from 0 to 10. What are they looking for an answer? Well, 1 point for the meaning of the expression. Somewhere in there you should mention that the temperature is dropping because it has a negative value. You should also obviously have the value of 23 degrees, and you also want to mention the time constraints, because if these limits of integration changed, let's say we went from 0 to 5, then we would only be talking about the time from 0 to 5. So mention the fact that it's dropping, mention the actual value, and mention the time constraints on that problem. And then part D. At time t equals 0, biscuits with a temperature of 100 degrees were removed from the oven. The temperature of the biscuits at time t is modeled by the differential function b, for which it is known to be blah, 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 blah. So now we've got an exponential function. Using the given models at time t equals 10, how much cooler are the biscuits than the t? So we need to know the temperature of the t, we need to know the temperature of the biscuits, and we need to find the difference between those two. Okay. So the temperature of the biscuits would be the initial temperature that they come out of the oven, that would be 100 degrees, and then the change in those biscuits. So we've talked about this in the past, but again, if you have a rate and you want a quantity, that would be an integral. If you have a quantity and you want a rate, that would be a derivative. So in the problem, they're giving you a equation b prime of t, which involves E, and we want to know the temperature for those biscuits. So therefore we need to take an integral from 0 to 10. So we're finding the change in the temperature there. Start with 100, calculate that change, and we get 34.18275. They like to list a lot of digits there in their solution manual. And then subtract the 2. So the temperature of the t minus the temperature of the biscuits gives us 8.817. The scoring on this is 1 point for the integrand. And remember, the integrand is the thing that you're taking the integral of. So if you're taking the integral of b prime of t, the function up above, then you're going to get a point for that. Second point, using the initial conditions that the biscuits come out of the oven at 100 degrees. And then your third point is recognizing that you need to subtract the 2 because the problem does ask you for the difference between the biscuits. As always, we've got a total of 9 points. 1 for problem 1, 3, 2, and 3, which adds up to 9. I have mine already set on this page, so I just did a quick graph of the data points that are here, here, and here, and here. And more than likely, when you see a chart problem, you're going to be asked to do one of two things. You're either going to do a Riemann sum or you're going to do a trapezoid rule. Back to this chart that I talked about earlier. So now what they want you to do is find the area under the curve using trapezoid approximations. Again, you could apply the trapezoid rule. I'm sure that some of you memorized that. However, I like to take a geometric approach, draw a quick sketch, and then find the area of each of those 4 regions using information from geometry, where this would be B1, this would be B2, this would be H, also known as delta X. And then for the second part, you'd have a B1 and a B2. And a quick refresher here, I'm sure you know this, but just in case, area of a trapezoid, whoops, 1/2 H times B1 plus B2. You'll also know that each of these shares a side, so 1 and 2 share the side at 2, 2 and 3 share the side at 5, 3 and 4 share the side at 9, 10 and 0 are not shared. Calculate the area of each of those.